Okay, so we are moving on to finding the area of shaded regions. In your learning target, you can calculate the area of shaded geometric regions. That's what you can do today. There's a process. I am going to draw a rectangular region that has a region inside them. Okay? And I'm going to tell you, hey, I want you to find the blue shaded region, please. Well, there's an awesome process. The first thing you would do is find the whole area. That means this whole outside area. That will give me everything. But it's not the whole area. You then have to find the inside area. The shape that's inside that outside shape. And then look, once you find that, if you take it away, you're left with just the shaded region. So if you would subtract the outside region, take away the inside region, gives you the shaded, right? Because the outside region gives you everything, but you want to take out this inside region, then you're left with the shaded region. Okay, so that's how you do. It just gets a little bit more advanced. Here's the formulas you need to know today. Circle is pi r squared. You're definitely going to need that formula today. You'll also need, on your actual homework, you'll need triangle. The formula for the area of a triangle is base times height over 2. Don't forget that. Okay, so this first example, I want to find the area of my gray shaded region. So I'm going to find my outside area, or the whole area. They're same thing. So my outside area is 12 times 5, which is 60 square centimeters. But that's everything, and I don't want everything. I want to take away this little triangle that's floating in the center. So I'm going to take away the inside shape. So my inside shape is that rectangle, and it's 8 times 3, which is 24 square centimeters. So if I take them away, what's 36, right? Just kidding, 47? Oh gosh.
36.
Okay, I second guessed myself. 36 square centimeters is that gray shaded region. Okay. Okay, the next one. Now here we start bumping up the rigor. Anytime you deal with triangles, it starts messing some kids up. Don't forget, the heart of circles, not triangle, the heart of circles is pi r squared. You have to have radius, and then you have to know if it's a whole circle, or half a circle, or a quarter of a circle. You have to know all that. So I still have an outside shape. That's my rectangle. So my outside shape is 5 times 10, which is 50 square centimeters. Now my inside shape is, how much of a circle is this? It's a half a circle. So my inside shape is pi r squared divided by 2. And it looks like my radius is 2.5. So it's 2.5 squared times 3.14, and I'm only half of it, so you divide it by 2. So I'm going to go 2.5 times 2.5 times 3.14 divided by 2 is 9.8. I'm going to just round to, I don't know, maybe we'll do 9.81. Ooh, doesn't really matter. Okay, and then I take this little baby circle area away, and I'm left with my shaded region. So it would be 50 minus 9.81 is a total shaded region of 40.91 square centimeters. meant 1, 9. Oopsie. It's not 9, 1. It's 1, 9. Silly me. 40.19 square centimeters.
Wait, I have a question. Like when you, like on the homework, for meters you said centimeter square, but then for inches and centimeter you said centimeter square.
No, I probably just misread. That's okay.
I didn't know if it had to be that way.
No, it doesn't. Moving to the next one. My outside shape. What's my outside shape? It's a square. And what are the dimensions of my square? 12 by 12. I'm not doing a good job at drawing my square, but it is a square. So my outside shape is 12 times 12, which is 144. That little apostrophe represents feet. Then my inside shape, what's my inside shape? It's a circle. And if that's the circle, then the formula for the area of a circle is pi r squared. Well, notice that this 12 is really the diameter of my circle. The 12 is the diameter. So I don't want the diameter, I need radius. So radius would be 6, right? So then the inside would be 6 squared times 3.14. Is 113.04 feet. Squared, oopsie, squared. And then take away 144, take away 113.04 is 30.96 square feet. Is the area of that green shaded region. Okay? Again, all I'm looking for is that I can identify what that outside shape is and that I know how to apply the area of a circle formula. So what's my outside shape on this next one? Huh? What's the outside shape? Circle. So it's a circle. What's the radius of that circle? Right? It's not 6 because 6 doesn't go through the center of the circle. Radius always touches the center of the circle. So my radius is 4, so the formula for the whole area of a circle is 4 squared times pi. So 16 times 3.14 is 50.24. And what's my inside shape?
Square.
It's a square. And so what are the dimensions of my inside square? 6, which means that the other side has to be 6. So it's 6 times 6, which is 36. So my total area of that shaded, gray shaded region is 50.24, take away 36, and that's 14.24, whatever the units are, squared. Okay, and then the most rigorous, you should recall seeing this. This is huge for 7th grade testing, especially from the state of Minnesota. They love to throw these shaded regions. Perhaps you remember ones like this and this on your OPAs. They love it. They love throwing that on there. This bottom one is definitely a level 4 type processing skill because they're trying to trick you and a lot of times they succeed. What are my two shapes? Circles. So I know it's going to be pi r squared. So then how many radiuses do I have? 2. I have 2 radiuses. Before you do your whole area, that whole process, this is where kids mess up. They think the big radius is 10, and they think the small radius is 1, and that's not true. My big radius what I do before I even apply anything is figure out what the heck my radiuses are. My big radius, so that's the big circle. The big circle is this outside circle. It goes from the center all the way to the end. So my big radius is 10 plus 1, which is 11 meters. Do you see? I have to go, if I do 10, I'm not all the way across to the big circle. I have to go that one more, and now I'm a whole radius. And that small radius, well, my small radius, let me just figure out what my small circle is, this cute little guy in the center. And then the radius of that little circle just goes to right there. Well, what's that number? 10. So my small radius is 10. And now I can figure, now that I know, and I'm not being impulsive, and that's where it gets to. Sometimes you just look and you're like, oh yeah, I'm just going to do pi r squared, and you just look for any number. Stop and think for a second and say, hey, is this really the radius? Does it go from the center all the way to the edge of the circle? Okay? And so now I need my whole area, which is that big circle, which would be 11 squared times 3.14, which is 121 times 3.14 is 379.94. And then I need my small circle, or my inside circle. I should be consistent. I should say inside circle. Well, my inside radius is 10, so it's going to be 10 squared times 3.14, which is 314. Take away, or find that difference, and you get 65.94 squared meters. And that's your learning target today.